Next problem. The slope of one of the straight line ax square plus 2hxy plus by square equal to 0 is twice that of the other. Show that 8h square equal to 9ab. So we know that if y is equal to m1x and y is equal to m2x are the two lines passes through the origin whose combined equation is, that is, you just multiply y minus m1x into y minus m2x equal to 0, right? Y minus m1x is equal to 0 and y minus m2x is equal to 0. Just to do the multiplication, y minus m1x into y minus m2x is equal to 0. So grouping that, you will get this equation: y square minus m1 plus m2xy plus m1 m2x square equal to 0 is represented by the pair of straight lines ax square plus 2hxy plus by square equal to 0. If it represents this pair of straight line, then you compare the coefficients. You will get m1 m2 is equal to a by b, that is equation number 1. Then m1 plus m2 is equal to minus 2h by b, right? That is 2, equation number 2. Suppose m1 equal to 2m2, right? The slope of one straight line ax square, that is given, right? Ax square plus 2hxy plus by square equal to 0 is twice that of other. So we are taking one straight line, slope of one straight line is m1 and the other straight line is m2. So we are taking the statement, that is, suppose m1 is equal to 2m2. Then 1 implies 2m2, substituting m1 equal to 2m2 in 1. 2m2 into m2 is equal to a by b. So 2m2 square is equal to a by b, that is equation number 3. And substituting in second equation, right? 2m2 plus m2 is equal to minus 2h by b. So 3m2 is equal to minus 2h by b, right? m2 is equal to minus 2h by 3b, right? That is equation number 4. Now using 4 in 3, so 2 into minus 2h by 3b whole square, right? So in 3 you are having 2m2 square equal to ab. So we are substituting m2 is equal to minus 2h by 3b in that equation number 3. So 2 into minus 2h by 3b square, which is equal to ab. So squaring numerator and denominator, 2 into 4h square by 9b square equal to a by b. So 4 into 2, 8h square by 9b square is equal to ab. So 8h square is equal to a by b, 9b square. So b and b square get cancelled on the right hand side. So you will get 8h square is equal to 9ab, which is to be proved. Next problem, prove that the equation to the straight line through the origin, each of which makes an angle alpha with the straight line y is equal to x, is x square minus 2xy secant to alpha plus y square equal to 0, right? So we have to prove straight line through the origin, right? Each of which makes an angle alpha with the straight line. So pair of straight line they have given through the origin, right? The pair of straight line both, right? There are two lines in pair of straight lines making an angle alpha with the straight line y is equal to x, right? Then the straight line is, that pair of straight line is x square minus 2xy secant to alpha plus y square equal to 0, right? We have to prove like that. We know if y is equal to m1x, that is equation number 1, and y is equal to m2x, equation number 2, are two lines passes through the origin whose combined equation is y square minus m1 plus m2xy plus m1 m2x square equal to 0. So we are using these results, right? Same results in each and every problem, right? This is the standard idea we are having. So equation 3. So x dash x axis, y dash y axis, O is the origin. So this is the line y is equal to x. Y is equal to x passes through the origin, exactly divides the x and y axis, right? Right? So we know the angle between coordinate axes is 90 degree. So x is equal to y exactly divides, bisects the coordinate axis, right? So y is equal to x bisects 90 degree, that means 45 degree each, right, on the one side of the line with the x axis, right? From x axis to the line 45 degree, from line to y axis 45 degree, right? That is 45 degree. This is 45 degree. So given that the line 1 and 2 makes an angle alpha with the line y is equal to x. So this is the pair of line, green line, right? That is first pair, and this is the second pair. So makes an angle alpha with y is equal to x square. Y is equal to x equal to is the orange line in the middle, right? So this is alpha and that is also alpha. That is what they have given. Let OA, OB and OC respectively represent the line 1, 2 and y is equal to x. So this is A, line A first, and line B second one, and y is equal to x is third line C. So XOC, angle XOC equal to angle YOC is equal to 45 degree. That is we know. And also angle AOC is equal to angle BOC is equal to alpha, right? That is also we know. Now angle XOA equal to angle XOC, right, minus angle AOC, that is 45 minus alpha. This one is 45 minus alpha. That is, similarly we are taking XOB. So XOB is equal to XOC plus BOC, right, other part. So 45 plus alpha, right? This is 45 then plus alpha. That one 45 plus alpha. Here inclination of 1 with the x-axis is theta 1 is equal to 45 minus alpha, right? So second equation inclination is theta 2 which is equal to 45 plus alpha, right? Right. So slope of 1 is m1 is equal to tan theta 1. So tan 45 minus alpha. So we know tan A minus B formula, tan A minus tan B by 1 plus tan A tan B, right? Instead of A and B we are having 45 and alpha respectively. So tan 45 minus tan alpha by 1 plus tan 45 tan alpha, right? So tan 45 we know 1. So m1 is equal to 1 minus tan alpha by 1 plus tan alpha. That is equation number 4. Now slope of 2, m2 is equal to tan to theta 2, that is equal to tan 45 plus alpha. We are using tan A plus B formula, tan A plus tan B by 1 minus tan A tan B. So 1 tan 45 equal to 1. So m2 is equal to 1 plus tan alpha by 1 minus tan alpha. That is equation number 5. Now using 4 and 5 in 3. So we will get the required equation of the pair of straight line, right? So y square minus, we are substituting the value of m1 m2, m1 plus m2 into xy, 1 minus tan alpha by 1 plus tan alpha plus 1 plus tan alpha by 1 minus tan alpha into xy plus m1 m2 x square. So 1 minus tan alpha by 1 plus tan alpha into 1 plus tan alpha by 1 minus tan alpha into x square equal to 0, right? This is the required pair of straight line. Now we are going to simplify that one. See, in this equation, first y square minus 1 minus tan alpha by 1 plus tan alpha plus 1 plus tan alpha by 1 minus tan alpha into xy. So in the other term, because 1 plus tan alpha in the numerator and the next nearby term 1 plus tan alpha in the denominator. Similarly, the first term 1 minus tan alpha in the denominator, and in the next term 1 minus tan alpha in the numerator. All get cancelled. You will get only x square, right, equal to 0. Now we are going to take LCM. So y square minus taking LCM 1 plus tan alpha into 1 minus tan alpha. Just to do the cross multiplication, 1 minus tan alpha into 1 minus tan alpha, 1 minus tan alpha square plus 1 plus tan alpha into 1 plus tan alpha, 1 plus tan alpha square divided by 1 plus tan alpha into 1 minus tan alpha xy plus x square equal to 0. So using y square minus then a minus b whole square, a plus b whole square formula, 1 plus tan square alpha minus 2 tan alpha, a minus b whole square, then a plus b whole square 1 plus tan square alpha plus 1 plus 2 tan alpha by, here a plus b into a minus b formula, a square minus b square, 1 minus tan square alpha into xy plus x square equal to 0. That is y square minus, see here minus 2 tan alpha plus 2 tan alpha get cancelled, 1 plus 1 2 tan square alpha plus tan square alpha, 2 tan square alpha by 1 minus tan square alpha xy plus x square equal to 0. Y square minus 1 plus tan square alpha by 1 minus tan square alpha, because we are taking 2 outside, right, xy plus x square equal to 0. So y square minus 2xy secant 2 alpha plus x square, right? Because 1 plus tan square alpha by 1 minus tan square alpha, which is equal to tan can be written as sin by cos, 1 plus sin square by cos square. Similarly, in the denominator, 1 minus sin square by cos square. Taking LCM, numerator cos square alpha LCM. So just to do the cross multiplication, in numerator you will get sin square plus cos square by cos square alpha. Similarly, in the denominator you will get cos square minus sin square by cos square alpha. So numerator denominator cos square alpha, denominator also cos square alpha get cancelled. So in the numerator sin square plus cos square, in the denominator cos square minus sin square, right? Sin square plus cos square is 1, so we will get remaining 1 by cos square alpha minus sin square alpha. We know cos square alpha minus sin square alpha is equal to cos 2 alpha, cos 2a formula, right? Cos square a minus sin square a. So 1 by cos 2 alpha, that is nothing but secant 2 alpha. That is why we have replaced. So the required equation is y square minus 2xy secant 2 alpha plus x square, which is to be proved. Thanks.